Good day, students. Welcome to part 4 of the midterm review. In this section, we're going to be focusing on operations on complex numbers, quotient, product, and powers of complex numbers in polar form, including the use of the moivre theorem. Let's go ahead and take a look at question number 18. Says what is 6 cosine 20 plus I sine 20 to the third power in polar form. So to do this, we're going to be applying the moivre theorem. Let's write down what the theorem is first, and we're going to apply it. So we have a complex number, r cosine theta plus I sine theta raised to the nth power. That is going to become the radius raised to the nth power times cosine of the power times the angle plus I sine the power times the angle. Okay, so you basically raise the radius to the power and multiply the power by the angles. That's what that's basically how you apply the moivre theorem to finding the powers of complex numbers in polar form. All right, so let's apply this formula to this situation. We have r is, you can clearly see that r is 6 and n is 3. And the angle theta is 20 degrees. Okay, so let's apply it here. So we have 6 cosine theta plus I sine, oh wait, let's fix that. 6 cosine, I'm going to make a substitution. 6 cosine 20, because that's the value of theta. 6 cosine 20 degrees plus I sine 20 degrees. We're raising that to the third power. Okay, so that's going to be 6 to the third, because we have the radius to the power, so 6 to the n, 6 to the third times cosine 3 times 20 plus I sine 3 times 20. All right, so that's how you have it. So it's going to become 6 to the third is 36 times 6 is 216 times cosine 3 times 20 is 60 degrees plus I sine 60 degrees. All right, so that goes the answer. So our answer for question number 18 is D. All right, let's move on to the next question. 19 says which of the following is a trigonometric form of the complex number the square root of 3 plus I. Alright, so we're going to change this to trigonometric or polar form, this complex number in a plus bi form. In order to do that, let's write down what the polar form of a complex number is. A trigonometric form is basically r cosine theta plus I sine theta. Okay, so we need to find r and theta. Okay, if I can find r and theta, then I'll just substitute the values into this formula, and that will be the trigonometric or polar form of this complex number. Okay. All right. So we're gonna apply two formulas that are included in your formula sheet. Let's call that up real quick. So we're looking for r and theta. So if you look on the bottom of your formula sheet, you see the formulas here for r and theta. This is to find r and theta, and then this is to find x and y. So we're going to be using the first set of formulas, okay? All right, so now to find r, we're going to be using the Pythagorean Theorem. So first of all, we need to find x and y, because r is, from the formula, is basically the square root of x squared plus y squared, okay? All right, so in this case, we have the complex number root 3 plus the coefficient of I is 1, right? Plus 1i. So this is x and this is y. Okay, so x equals root 3 and y y equals 1. So that's what I'm going to plug into this formula. So we're going to have the radius equals the square root of root 3 squared for the x plus 1 squared for the y. Alright, that equals square root of root 3 squared is 3 plus 1 squared is 1 equals root 4. The answer is 2. So r is 2. Okay, now we need to find theta. Going back to the formula, you find out that theta is equal to the inverse tan of y over x. Okay, and if x is let's go back to the formula. Let me show you a very quick detail. If x is negative, we have to add pi. If x is positive, we just leave it alone. Okay, in this case, we see that x is greater than 0, so we do not have to x is greater than 0, so we do not have to add anything to this formula. Okay, alright, so let's make use of the formula. So theta is going to be the inverse tan of y over x, which is 1 over root 3. Um, let's simplify. Let's convert this into a form that's consistent with what we had on our unit circle. So 1 over root 3 can be simplified. You multiply by root 3 and root 3 on the top. And then we have root 3 over 3. Okay? So it's the same thing as taking the inverse tangent of root 3 over 3. Alright, so let's go back to our table of common trig angles and find out what the inverse tan of root 3 over 3 is. So let's see. There you go. Alright, so we have root 3 over 3. Where are you? For tan, root 3 over 3 basically takes you up to 30 degrees. Okay, so the tan of root 3 over 3 right here takes you straight up to 30 degrees. So that's what inverse tan of 30 is. So let's go ahead and do that. So it's going to be, theta is going to be 30 degrees. Alright. Now that we have theta and r, we're going to put them together into the formula. So it's going to be, r is 2 times cosine theta, which is 30 degrees, plus I sine 30 degrees. And there goes your final answer. This is the polar form of root 3 plus I. Okay? So the answer is option letter B. Alright, let's move along to the next question, number 20. Alright, so for 20, we want to convert this complex number in polar form into a rectangular form. So we have 14 times cosine 4 pi over 3 plus I sine 4 pi over 3. Okay, so we just simply use our chart to evaluate these trig values, and then we'll distribute 14 into both of them. Okay, so let's just bring down the 14. Now 14 times cosine 4 pi over 3. Let's see, cosine 4 pi over 3. We're gonna call up our unit circle. Actually, we can just use our table of trig ratios to do that. So cosine and sine of 4 pi over 3. If you look here, cosine 4 pi over 3 is negative 1/2, and sine 4 pi over 3 is negative root 3 over 2. Okay, so negative 1/2 and negative root 3 over 2. The sine and cosine values of 4 pi over 3, which is also equal to 240 degrees. Alright, so let's go ahead and put that in. From our chart, cosine 4 pi over 3 is negative 1/2 plus sine 4 pi over 3 is negative root 3 over 2, so negative root 3 over 2i. Let's simplify that a little bit, so we have 14 times negative 1/2 minus root 3 over 2i. Now, to finish this off, we'll just simply distribute 14 into both of these. So we're going to have, it's going to equal negative 14 over 2 minus 14 root 3 over 2i. This I can divide by 2 top and bottom. So that will give me negative 7 And then this one divided by 2 top and bottom, you have negative 7 root 3i. And there goes your final answer of 14 cosine 4 pi over 3 plus I sine 4 pi over 3 in rectangular form. So our answer is option letter B. Alright, let's move on to question number 21. We have to find 1 minus I root 3 raised to the 12. We can use the moivre theorem here, but let me just show you a trick using a calculator to do this. To do this with a calculator, we can just go parentheses 1 minus where's I? Where are you? I root 3 raised to the 12th power. Yeah, and you can see that it's 4096. Okay. All right, so our answer is going to be option letter A. So this is equal to 4096. All right, let's move on to the next question, question 22. We're going to be applying the quotient property for complex numbers. So when you're dividing two complex numbers, z1 and z2, the quotient is basically r1 over r2 times cosine theta 1 minus theta 2 plus I sine theta 1 minus theta 2. Okay? So basically, you find the quotient of the radii, and then you multiply it by cosine of the difference of the angles, and I sine the difference of the angles. All right, so we can see in this problem, R1 is 21, R2 is 3. I don't know where that came from. R2 is 3, theta 1 is 55, and theta 2 is 65. All right, so let's compute z1 over z2 using the formula indicated above. So r1 over r2 is going to be 21 over 3, okay, times cosine theta 1 is 55 minus theta 2, 65, plus I sine theta 1, 55 minus theta 2, 65. Okay, so it's going to be 21 over 3 is 7. 7 times cosine negative 10 plus I sine negative 10. And there goes your final answer. So our answer is option letter D. Alright. Okay, so it says, question 24 says, find the value of A so that vectors U, which is AI minus 9J, and vector V, which is 4I plus 4J, are perpendicular. So to do this, the two vectors are perpendicular. That means U dot V has to be 0. Okay, so what we're going to be doing is we're going to be solving an equation, which is U dotted with V equals 0. Okay, so let's go ahead and do that. So U dot V is AI minus 9J dotted with 4I, like I said, J, 4I plus 4J, 4I plus 4J equals 0. Okay, so to find the dot product in this ij form, you just multiply the i's and the j's and find the sum of the products. Okay, so it's going to be a times 4, that's the i's, and then the j's plus 9 times, actually negative 9 times 4 equals 0. Alright, so you have 4a minus 36 equals 0. Alright, to get a by itself, you add 36 and divide by 4. Alright, let's go ahead and do that. Add 36, you have 4a equals 36, and then divide both sides by 4, and then your final answer, a, equals 9. Alright, so when a is 9, vector u is going to be perpendicular to vector v because your dot product will be 0. Okay, so there you have it. Alright, let's move on to the last question. It says true or false if tan x is root 3, then tan 2x is negative root 3 over 2. So I'm going to show you how to do this using a calculator. So first of all, let's see what this value is. What's tan 2x? Tan 2x is equal to negative root 3. What is the approximate value of negative root 3? Let's plug that into our calculators and see what we get. Write that out. Negative root 3 is negative 7321. Negative 7321. Okay, so it's approximately negative 1.7321. Alright, now let's use this to find tan 2x. So we know that tan x is root 3. If tan x is root 3, then what is x going to be? You take the inverse tan of both sides, right? So you take the inverse tan of tan x equals the inverse tan of root 3. Let's divide out. So you get x equals the inverse tan of root 3. Now we're looking for tan 2x, right? So what is 2x? If x is inverse tan over 3 and 2x, you multiply both sides by 2. 2x equals 2 times the inverse tan over 3. So we want to find tan of 2x. This is 2x, so the tan of 2x is tan of 2 times the inverse tan of root 3. Okay, alright, let's plug this into our calculator and see what this is approximately equal to. If this is equal to that, then our statement is true. If it's not, then the statement is false. Alright, so let's go ahead and do that. Tan of 2 times the inverse tan over 3, negative 1.7321 is approximately negative 1.7321. So we have a match. They're both equal. So guess what? The statement is true. Alright? So that's that. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking up here and click like if you like this video. And please post a comment to let me know what you think about this clip. More clips coming from MacBookServe.com. Thanks again and have a wonderful day.